So folks, in this problem, we're asked to find the location and values of the absolute extremum for this particular function on this closed bounded interval. So we're going to tackle that in just a second. In my math lab, they gave us a sequence of choices. I want to talk about why D is certainly not an answer to this question. Notice that f of x, which I could rewrite in this form just to help us see it a little bit better, is continuous on the interval from -1 to 6. But if that's the case, then the extreme value theorem guarantees that there's an absolute max and absolute min on this interval. So it's impossible for there not to be solutions to this problem. That won't always be the case, but it will be the case as long as your function is continuous on a closed bounded interval. Okay, so the next thing we want to do is we want to look at our steps for finding absolute max and mins. So the first thing we're going to do is we're going to find the critical numbers on the interior of that interval. So find the critical numbers. So we'll figure out where the derivative is either 0 or where the derivative is undefined for values within that interval that I've just listed. The second step is to evaluate the function at the critical numbers and at the endpoints. Folks, I can't emphasize enough how important it is for you to compartmentalize these two tasks. One is the task of evaluating the critical numbers, and the other is the task of evaluating the endpoints. The last thing we're going to do is just classify the extrema. So let's jump into it. So the first thing we need to do in step 1, we need to find our critical numbers on the interval from -1 to 6. So to do so, let's look at f prime of x. So for f prime of x, I guess I should recopy the function. So f of x is the function 4x cubed e to the minus x. I'm going to use the product rule on this. There's many ways to find the derivative. I'll use the product rule. So here's my first times the derivative of the second, where that -1 comes from the chain rule, plus the second function times the derivative of the first. Let's clean that up. So this cleans up to be, I'll write this as 12x squared e to the minus x minus 4x cubed e to the minus x. I don't think it's very easy to identify the critical numbers when it's in this form. Let's first rewrite each of these as fractions. Now I think it's a little bit easier. We'll combine them as a single fraction. We'll go ahead and do some factoring. So now I think we're in a position to identify where f prime of x is 0 or undefined. Notice that f prime of x is never undefined in this case. Although in many other cases you might have places where the derivative is undefined. F prime of x equals 0 at x equals 0 and at x equals 3. We see that by asking ourselves the question, when is the numerator of the derivative equal to 0? And so we could say, what numbers could I plug in for x that would make that numerator 0? So now I'm in a position to identify what the critical numbers are. The critical numbers are x equals 0 and x equals 3. It's really important to me, folks, that you realize that one thing I did just now was I checked to see, are those points in the interval from from -1 to 6. And if you're confused about that, what I'm checking to see is I'm checking to see if they are in the interior of the domain we were given, which was the closed bounded interval from -1 to 6. So the only interior points would be these points here. Notice that both x equals 0 and x equals 3 are inside that interval, so we include them as critical numbers. If they weren't, we would not count them as critical numbers. So now I think we're ready for step 2. Let's go check that again. Step 2 said to evaluate the function at both the critical numbers and the endpoints. It is essential that you remember to check both the critical numbers and the endpoints when doing this, because absolute extremum could occur either on the interior at critical numbers or at the endpoints. So let's go ahead and let's see here. Our f of x was the function 4x cubed e to the minus x, and we're going to evaluate f of 0, and we're going to evaluate f of 3, but we're also going to evaluate f of 1, f of negative 1, and f of 6. It's important to me that you realize the reason why I'm checking these points right here is because these are the critical numbers of f, and these are the endpoints. Okay. So we're checking these 4 points, in this case, is what we have. But we're checking 2 of them because they are critical numbers. We're checking 2 of them because they are endpoints of the domain. So let's go ahead and evaluate f of 0. That one is 4 times 0 cubed e to the minus 0, but that just comes out to be 0. Then we're going to go ahead and evaluate f of 3. So that's 4 times 3 cubed e to the minus 3, which I believe simplifies to be 108 over e cubed. And although that's a nice place to leave the answer, to compare it with the others, I might want to do a decimal approximation of that. And if I do a decimal approximation of that number, I got 5.37 abouts. The next thing I want to do is evaluate the 2 endpoints. So let's see here. F of negative 1 is 4 times negative 1 cubed e to the minus, careful, watch your negatives, minus a minus 1, which comes out to be negative 4e. And again, I'm going to compare this to some of the other numbers potentially. In this case, I won't because it's already negative. But I'm going to compare this to the other numbers, and I get that that's roughly negative 10.87. So this is the proper way to leave your answer. This is what you might use to compare it to others. So let's go ahead and evaluate f of 6 now. So that's going to be 4 times 6 cubed e to the minus 6, which is the same thing as 864 all over e to the 6th. And again, I'm going to need to compare that, so let's do a decimal approximation of that. And when I did so, I got approximately 2.14. All right. So folks, one thing to double check. Notice that I plugged everything into the original function. I'm looking for the absolute maximum and minimum values. Although I use the derivative as a tool to help me find the absolute maximum and minimum values, when I want to find out what the y values are on a function, I don't plug those numbers into the derivative. I plug them into the function so that it outputs the height, if you will, of that y value, that point on the curve. Okay? So step 3 is to go ahead and classify these points. So let's go ahead and do so. I think that this function has an absolute minimum value of negative 4e, and that occurred at the x-coordinate negative 1. So careful, folks. There's the ordered pair that is the absolute minimum value. The absolute minimum value is a value of minus 4e, and that happens at the x-coordinate negative 1. And then as I'm looking through this list, which of the values on this list gave me the greatest y value? And so we're going to have an absolute maximum. That maximum value is 108 over e cubed, and that occurred at the x-coordinate 3. So now we've answered this question. We could go up here and enter it into my math lab. So we have the absolute maximum value is 108 over e cubed, we saw, and that occurred at the x-coordinate of 3. And the absolute minimum value of minus 4e, and that occurred at x equals negative 1. Let's go ahead and look at a graph of this real quick. So here I've gone to Desmos.com. Let's go ahead and take a look at the graph of this function. There's the graph of this function, and we want to restrict ourselves to a particular interval. So I'll add to this for -1 less than or equal to, how do we do that? Less than or equal to x less than or equal to 6. And I'll monkey with the window real quick. So I want my y values, or my x coordinates, to go from minus, let's go 1.1, so we can see a little ways down, up to 6.1. And I want my y values to go from maybe -12 to, looks like maybe 6. And folks, hopefully, let's see here, it looks like you can't quite see the whole graph based on how I'm filming this. So I'll take this out a couple more spaces. Hopefully that brings the whole picture into view. And yes, it looks like you should be able to see the whole graph here. So we see that the absolute maximum value, that occurred right here at x equals 3. That gave us the y value that we expected. Notice the absolute minimum value, that occurred down here at x equals -1 with the y value we expected. But notice that we also checked the x-coordinate of 0, and we also checked the x-coordinates of 6, because if we were doing this problem blindly, like we did initially, without being able to see the graph, we had to know all the points to check. And so we checked 0 because it was a place where we had a critical number. The first derivative was 0 here, just as it was for 3 up here. Notice we've got a horizontal tangent line at both those locations. And we also checked -6 as a potential location, and we checked -1 because those were the two endpoints. And that left us with our answer that the absolute minimum value was at -4e, or was of -4e, and that occurred at x equals -1, and that the absolute maximum value was 108 over e to the third, and that occurred at x equals 3. We were able to do all of this without ever looking at the graph, which is important as we get into more complicated functions. As you get further and further along into your math career, the functions will get messier and messier, and you won't be able to simply sketch them the way we were able to sketch them in Desmos in this case. Folks, if you have any questions on this video, please let me know.